All right, so I have taken this problem from trig review number 3, and this is problem number 2. So it's saying a right triangle has a short leg that is 7 centimeters and a hypotenuse that is 13 centimeters. And it wants us to find all of the angle measures. Okay, so let's go ahead and draw a right triangle. So here is my right triangle. And my right angle is going to be right here. Now, it gives us two sides. It gives us the short leg and the hypotenuse. Well, we know that the largest angle in a right triangle is this 90-degree angle. Okay, so that means that right across from it is going to be the longest side. And the longest side is also known as a hypotenuse. So we know that this side here is 13 centimeters. And we're given that a short leg is 7 centimeters. So now we just have to decide which is the short leg. Now this is not really drawn to scale, so I'm just going to choose one side to be 7 centimeters. I'm going to choose, let's say this side right here, 7 centimeters. Now this problem is asking us to find all of the angle measures. Well, we know one is 90, this one right here in red. Now we are asked to find these other ones. So let's go ahead and find this first one. I'm going to call this angle A right here. I'm also going to color it. So this angle A. So let's see. Let's label the sides of this right triangle with respect to this angle. So we know that this, the longest side, is the hypotenuse, no doubt about it. And we have this side that is next to this angle. So this side right here, the 7 centimeters, is the adjacent side. So I'm going to write adjacent. Okay. Now, in order for us to find this missing angle, we need to know at least two sides, which we do. Okay, and then we can use what is called the inverse trig functions. Okay, so we need to see which trig function relates the adjacent side with the hypotenuse. So pause the video, look at your notes, analyze your notes, and determine which trig ratio do we need to figure out this problem. All right, now that you've paused your video and had time to analyze this, the trig ratio that we need is the cosine. So the cosine of this angle A is going to be equal to the adjacent side, which is 7 centimeters on top, and the hypotenuse goes on the bottom, which is 13. All right, now I'm going to rewrite this trig ratio. Okay, remember our goal is to find this angle A. So we need to do something to get there. So we have 13 here. So the way to get rid of this cosine is to actually take the inverse. So we do cosine inverse, and the inverse looks something like this with a -1, and then you have these parentheses. So whatever we apply on this left-hand side of this equal sign, we need to also apply on this right-hand side. So this is going to be cosine inverse. All right, so now what happens is that this cosine inverse undoes this cosine, or undoes. In other words, they cancel each other out. So we're gonna get left with the letter A on the left of the equal sign. And on the right-hand side, we're gonna get left with the cosine inverse. And then 7 on top and 13 on the bottom. Now, when you plug this into your calculator, make sure that your calculator function is in degrees. Okay, make sure it's not in radians, but in degrees. So once you plug this in, you're going to get approximately 57 0.20, 0.42. All right, so that's the angle. And now given this information, we're able, so now we know this angle A, and we know that this other angle is a 90-degree angle. Now we can figure out what angle, let's call it B is. So I'm going to shade it right here. All right, well, we know that angle B plus angle A has to give us 90 degrees. Okay, so therefore, angle B is approximately equal to 32.58. And so this is just one way of approaching this problem. Of course, there are multiple ways on how to solve this.